Imagine waking up to a notification from OpenAI or AWS telling you that your monthly bill is not $200, it's $42,000. And the worst part, your site was never down, no server crashed, no customer complained about 500 error, and everything ran perfectly. Welcome to the world of denial of wallet attacks. While traditional DDoS attacks try to break the app, the denial of wallet attacks target something which is much more fragile, which is your bank account. In this video, we are looking at how malicious actors exploit pay-as-you-go LLM pricing and why standard rate limiters fail, and then we are going to open VS Code and write a production-ready code for token bucket rate limiter in Python and FastAPI and Redis, so your cloud bill never explodes. Economic denial of service isn't brand new, but the generative AI surge has made it exponentially worse. In traditional web development, a single malicious request to an API costs fractions of a cent in compute. To burn through $10,000, an attacker needs to send tens of millions of requests. That traffic spike usually triggers traditional WAF or web application firewalls or basic IP rate limiters. Now consider an AI application. If your application uses RAG, multi-turn conversational memory, or autonomous agent, the cost of a single user prompt isn't static. An attacker doesn't need millions of requests. They just need amplification. By crafting a single complex query, say asking your assistant to summarize a massive document, running 10 parallel search tools, and generating a 4,000 token response, a single prompt can cost you half a dollar or more. Now send that request 10 times a minute using a distributed botnet, and an attacker can drain thousands of dollars from your budget in hours. And that too completely under the radar of standard request per minute filters. Why do standard cybersecurity tools fail here? Most rate limiting algorithms like fixed window or leaky bucket track one metric, requests per minute, or RPM. They treat a 5-word query like what's the weather the exact same way as a 50,000 token prompt like analyze this entire PDF, pull 15 context chunks from the vector database, and write a recursive Python script. To your rate limiter, both equal one request. To your OpenAI or Anthropic invoice, one costs $0.0001 while the other will cost $0.30. That is 300 times cost disparity. Now imagine if your limit is set to 60 requests per minute per user, an attacker can consume $18 per minute per account without even triggering an RPM alert. Now multiply that by a few dummy accounts and rotated proxies, and your monthly budget vanishes before the breakfast. So how do we solve this? You have to move from volume-aware rate limiting to cost-aware rate limiting. Instead of counting HTTP requests, we need to track tokens per minute or TPM using an atomic token bucket algorithm. Let's jump into the code. We are using FastAPI, Redis, tick token, and an atomic Redis Lua script. The first challenge is race condition. If 10 requests hit your API at the same millisecond, standard Python code might read the user's token balance before updating it, letting all 10 requests go through. To make it thread safe and atomic, we write a Lua script that executes directly inside the Redis. Have a look at this code. We have included the Lua script inside our Python code. I'll show how to execute it. The first step is to get the current bucket state. Then we have to initialize the bucket if it doesn't exist. Notice what's happening here. Redis calculates how many tokens were refilled since the user's last request based on elapsed time. If they have enough tokens, it detects them instantly. If they don't, it denies the request and tells us exactly how many seconds we need to wait before trying again. At the startup, we are going to load the Lua script. Now here's the trick with LLMs. You don't know final token count until the LLM finishes generating. To fix this, we implement a two-phase reservation pattern inside our FastAPI route. We'll first identify the user and then we will estimate the worst case token usage. Here we are going to use tick token and the model which we are using here is GPT-4o. To get the worst case token usage, we are going to pass the prompt tokens plus the maximum number of tokens which will be possible. The next step is to reserve or consume tokens from Redis. Notice here we are using await to limit consumption. If the token budget exceeds, we will tell it to try again after a few seconds. The step 4 is to call the LLM service safely. And finally, we are going to reconcile usage, which is to refund over-reserved tokens. Before calling OpenAI or Anthropic, we reserve the worst case scenario. Once the LLM finishes streaming, we check the actual usage and refund unused output tokens back into the user's bucket. If the API crashes, we refund everything so the user isn't penalized for server errors. Application level rate limiters are your first line of defense, but you always need an infrastructure safety net. Even if an attacker finds a loophole in your code, your cloud provider shouldn't have a free rein over your credit card. Multi-tier billing alerts don't just set an alert at 100% of your budget. Set triggers at 50%, 75% and 90%. Automated kill switches set up cloud functions or webhooks. If daily spend crosses an emergency threshold like $500 in 1 hour, automatically route your incoming request from a high-cost model like GPT-4o to a cheaper fallback model like Llama Lite or throttle non-critical background workflows. In the age of AI, cybersecurity isn't just protecting your data. It's about protecting your runway. To recap, stop relying on simple request per minute rate limits. Build cost-aware, token-based rate limiters using atomic operations in Redis. Reserve tokens before calling the LLM and reconcile actual usage afterwards. I've left a GitHub link in the description below for the full FastAPI implementation so you can drop it straight into your stack. How are you currently monitoring your AI token costs? Have you ever had a runway cloud bill? Let me know in the comments. Don't forget to like and subscribe for more production AI and DevSecOps contents. I'll see you in the next one.